Good morning and welcome to the next class on friction. In the last two periods, we have been learning about friction. Let's do a quick recap of everything we have done on friction. Friction is a force that we can observe when there is relative motion between two objects. So when there are two objects and one is moving with respect to another, then you can see the force of friction. There are many things you have to then understand. One is friction is a contact force. When two objects come into contact with each other, when there is rubbing between two objects, there is friction. Second, friction is a kind of force. So it has magnitude and direction. It is a vector quantity. Third, friction always opposes the motion. If a body is moving in one direction, the force of friction acts in the opposite direction. And we have seen all these through simple activities in the last two classes. I had asked you one question in the last class, and I wanted you to think about it. So let me show you the question again and then pause for a minute and see if anyone has an answer. This was the question I had asked. So there are two ways of moving the block. One is to push and the other is to pull. The pictures are given here. So my question is, which way is easier? You're moving the block by pushing it, you are moving the block by pulling it. Now which of these two will be easier and why? Now again, this was a question for you to think about, and I will leave it to you to think about it. Okay. So for those of you who did not write down the question or did not understand it the last time, I'll leave it here for a bit. Write it down and think about the answer. In the last class, we learned one other thing about friction. So if you have a table top and then you keep an object here and there is a force of F trying to move the block, then there is a force of friction which acts in the opposite direction. If this force is acting on the block trying to move it, then the force of friction acts in the opposite direction. Right? And we know this because friction always opposes the motion. And in the last class, we discussed the factors that affect friction. Friction depends on two factors, I said. And through some simple activities, I had shown it to you. The first is the weight of the object. As the weight of the object increases, then the force of friction increases. Second thing is friction changes, or friction depends on how smooth the surface is. If it is a very rough surface, it will offer greater friction than if it is a smooth surface. So it depends on two things: the weight of the object and the nature of these surfaces. And some simple activities that I did in the last class illustrated this point. Okay. So this was the summary of what we did in the last two classes. Now let us look at something new about friction. So let me show you a couple of pictures now. I want you to think about it and tell me what you see, what you observe. Anything that you can think of uh, about this picture, you can let me know. So you can see him sliding so easily across the ice. This is an ice rink. And this activity is called ice skating. So what can you observe? What do you think about the friction? So the friction between the ice and his skating shoes is very low. So there is very little friction between his, you look at his shoes, the kind of special skating shoes he is wearing. And remember, he is on an icy floor, it's covered with ice. So the friction is very low. That is why he can slide so easily on ice. The friction is very low, and that is why he can slide like that on ice. Do you think you can do this on ground, on a regular road, or on the floor of your classroom? You cannot, because the friction is quite high. You need friction to be very low to slide like this. Let's look at another picture and you tell me what you think. This is the man falls into the pool. Look at how he is moving. The floor here, the floor is wet. The floor is wet. So when we say the floor is wet, we also say that the floor is slippery. Now, what does the word slippery mean? It means that the friction is low. The word slippery, when we say that the floor is slippery, be careful. What does it mean? It means that the friction is low. And so, the floor is wet and slippery. This means there is little friction, not much friction, very low friction between his feet and the ground. And that is why he slips and falls. So when we say the floor is slippery, it means that there is very little friction. So you have to be careful walking on such a floor. Let us look at one more picture, and I want you to think about what this means. Remember, we are talking about friction. You may have played this game. We use powder on the carom board to reduce friction, so that the pieces can move easily. The striker can move very easily. You look at it, it moves so smoothly over the board. If the friction is high, it won't move smoothly over the board. You'll have to hit it much harder. None of the other pieces will move so easily, and so on. So you reduce the friction by using a certain kind of powder. So all of these examples, and we've seen 3 examples here. This is an activity where you want the friction to be low. You want friction to be low so that the person can slide easily across the ice. This is a situation where the friction between his feet and the floor is very low because the floor has become slippery. It is wet and he falls into the water. This picture is, and we've all played this game, you want friction to be low. So we use a special kind of powder on the board to reduce the friction. So all of these are examples about how we deal with friction, or what happens when there is friction. So let's look at these examples again. This is a situation where you want very little friction because you want him to slide easily on the ice. This is a situation when you're walking, you want some friction, otherwise you will fall. And again, this is a situation where you want less friction because you want those pieces to glide, to slide very smoothly on the board. So in these situations, there are 2 of them where we want less friction and 1 where we want higher friction. Now let's talk about something called friction, a necessary evil. Now, what do these words mean? A necessary evil, what does that phrase mean? So when we say necessary, we say we need it. It means that we need it. It is a good thing. And that is why we need it. But what does the word evil mean? We don't want it. It is not a good thing. So how can something be both? This is the opposite of that. On the one hand, the word necessary means we need it. It's a good thing. The word evil means we don't need it. We don't want it. It is not a good thing. So how can friction be both? That is what we will learn about in this class. Can you do any of these without friction? Just think about it. Walking. You would not be able to walk without friction. Just remember what happens in some of these situations. Take a look at what happened, for example, here. You remember seeing these pictures. So what happened? The simple act of walking is not possible if there is no friction between our feet and the ground. Okay? What happens when you want to brush your teeth? You're holding the brush in your hand. You cannot hold anything with your fingers if there is no friction. For example, if I want to hold a pen and write, I need friction between my fingers and the pen. If there is no friction, the pen will simply fall out of my hand. Even to write something on the board, there has to be friction between the pen, the nib, and the board. Otherwise, I will not be able to write. So I cannot walk, I cannot run, I cannot hold the brush, I cannot hold anything. Even cleaning our teeth, there is friction between the brush and the teeth. Holding a cup, there is friction between our fingers and the cup. Writing, wearing clothes, everything we do needs friction. We could not do any of these things without friction. So that is making the point that it is necessary. We need it, because without it, we cannot do anything. So friction is necessary. Friction is good. Otherwise, we can't walk, we can't run, we can't hold anything in our hands, we can't wear clothes, we, we can't write, we can't do anything. So friction is necessary. What happens when there is no friction? You've seen this. We fall. So friction is necessary. In this example, friction is necessary between our feet and the ground. What about this? These pictures, these examples. Friction is necessary between the wheels and the ground. Here, friction is necessary. Between the feet and the ground. Otherwise, you will slip and fall. You cannot walk. What about these pictures? Friction is necessary. If the car has to move forward, friction is necessary between the wheels and the ground. Otherwise, the car will not move forward. The car just stands there. You can see that the wheel is turning, but the car does not move forward. And why does that happen? Because there is no friction. So friction is necessary once again. The bike was able to stop, but the auto did not stop. Why? Friction is necessary to stop the vehicle. Otherwise, brakes will not work. When you apply the brakes, the bike or the auto or the car will stop. How do brakes work? They work using friction. So you look at all these examples so far, friction is necessary to walk. Friction is necessary for the car to move forward. Friction is necessary to stop the vehicle. So we have seen so many examples where friction is necessary. Friction is needed for almost everything we do. Right? We started with some of these actions, walking, running, holding something with our hands. All of these are possible because of friction. Let's just take a very simple example. As I stand here in front of you, trying to write something on the board, my glasses stay here because of friction. I'm holding the pen because of friction. I can stand without falling because of friction. I can write something on the board because of friction. What would happen if friction was not there? Would I be able to do anything? No, I would not be able to do anything. Right? I'm wearing a belt that stays there because of friction. So friction is necessary for a lot of things that we do. Okay, but why do we call it evil? Necessary evil. Necessary means we need it, but evil means something that we don't want. So why do we call it evil? Can you think about what is bad about friction? I will give you just a little bit of time. Think about when friction is necessary for almost everything we do, why do we call it evil? Just take a little bit of time and think about why we call it evil. Think about it. Can you think of an example where friction is bad, where we don't want friction, where friction does something which we don't want? Well, let's take a look at some situations where friction is not good. Friction causes wear and tear. What does wear and tear mean? Whenever there is constant rubbing, when there is constant friction between any two objects, it causes wear and tear. Now, there are lots of things that undergo wear and tear because of friction. This is just one example of the shoes. They undergo wear and tear. You can see that the sole of the shoe has got a hole in it because of the friction, and that is called wear and tear. There are lots of parts, machine parts, that undergo wear and tear. Shoes undergo wear and tear. Um, Clothes may undergo wear and tear because of friction. The brakes of vehicles may undergo wear and tear because of friction. So there are a lot of things that get damaged because of the wear and tear of friction. So that is one important reason why it is not good. Friction is not good. The other is any machine converts one form of energy into another form of energy. For example, a car engine converts the energy of the petrol to the mechanical energy of the car moving forward. So any of these machines, any machine you think of, will convert one form of energy into another form of energy. For example, an electric fan will convert electrical energy into mechanical energy. A radio will convert electrical energy into sound energy. So any machine you think of will convert one form of energy into another form. But machines have moving parts. So there are moving parts and there is friction between the moving parts. So when there is friction between the moving parts, I told you earlier, friction causes heat. And a simple demonstration of that is this: friction causes heat. So when there is friction between moving parts of a machine, there is heat produced. Now that heat energy is a waste of energy. We want energy to be converted from electrical energy to mechanical energy. But some of that energy is getting wasted as heat because of friction. And that is another reason why friction is not a good thing. The first is friction causes wear and tear. Second thing is friction generates heat in machines. So this is a waste of energy. So these are just two reasons why friction is not good. And now you begin to understand why we call it a necessary evil. We need it. It is necessary for a lot of things we do, but in certain situations, it is not good. So let's take a look at some specific situations and see whether friction is a good thing in those situations or a bad thing. Walking. What is the role of friction? You cannot walk without friction. So friction is necessary. You cannot walk on the ground without friction. But it causes but the shoes and the chappals or whatever footwear we wear get worn out because of friction. Driving a car, the wheels need friction, otherwise the car will not move forward. Friction again is necessary for the car to move. But it also causes wear and tear of the tires. So in each example, you can see that it's a good thing and a bad thing. For writing with a pencil, you need friction. Friction is necessary for you to hold a pencil, for the pencil to write on the paper. But it also causes wear and tear. Holding a cricket bat, you cannot hold a cricket bat unless there is friction between your hand and the bat. Putting a nail in the wall. If there is a wall like this, and you want to put a nail like this inside the wall, how does the nail stay inside the wall? How does the nail stay inside the wall? The nail stays in the wall because of friction. So friction is necessary. So you can see that here we have a set of examples where friction is necessary in some cases and causes some damage in other cases. Here, friction is necessary for brakes to work. So in each of them, we saw examples where friction is both necessary and an evil. And that is what I meant by it is a necessary evil. Let's do some of these simple questions. Friction opposes the blank between surfaces in contact with each other. This one is, I'll give you maybe a minute to think about these 4 blanks. Try and see what you can do with it. So, well, friction opposes motion between the surfaces in contact with each other. Friction depends on the dash of surfaces. We can say smoothness. We have seen this in a simple activity. The smoother they are, less friction there is. Friction produces heat. We have spoken about it once or twice. Sprinkling of powder on the carom board reduces friction or decreases friction, or we can say decreases friction, and that is why we use that powder. So these are some simple questions about friction in daily life. So summarizing what we have learned today, friction is essential for so many of our activities. Even simple actions would not be possible without friction, like walking or running or holding something. So it is necessary. But friction also causes wear and tear of moving parts. Friction between 2 parts generates heat, which is a waste of energy. So there are situations where we need friction, but it also causes problems. Hence, friction is called a necessary evil. And that is what we learned today. I'm going to end today's class by doing a simple activity. I would want all of you to try it. And all you need for this activity are 2 books. So if you have 2 books of any kind, it could be 2 textbooks, 2 notebooks. Let's do this activity. And so I have here 2 books. It does not matter what these books are. Okay, so we have the situation where we have 2 books. What I'm going to do is open these books like this, and you have to put 1 page of this and 1 page of this. Now 1 page of this and 1 page of this. 1 page of this. That's all you have to do. So what I'm doing is just 1 and 1. And you can do it for about a couple of minutes. We need about 20-30 pages to be arranged this way. So let me take a minute and do that. Remember, these are just pages of 2 different books. I have not pasted them with glue or gum or anything like that. All I'm doing is putting these pages one after another. You'll have to do it for a minute or so for this experiment to work. Just, let's say, 10 more sheets. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then all I've done is like this. Remember, there are 2 separate books, and I just interleaved the pages. What I want you to try to do is separate the books, pull them apart. You cannot. It's very difficult to pull them apart. They are stuck so tightly. Remember, these were 2 different books. I did not paste them. I did not put any pins or glue or anything like that. Just by putting 1 page after the other, these 2 books are held so tightly now, I cannot pull them apart. And why is that? That is because of friction between pages. I cannot pull them apart. So now I'm beginning to pull them apart. The friction between the pages is so high that the books are held together very tightly. So this was a simple demonstration on friction. We have learned about why friction is called a necessary evil. In the next class, we will learn something more about friction. See you in the next class.